So let's take a look at that previous example. And what I want to do is I want to find the equation of the line that's tangent to the graph when x equals 2. Well, right away that creates a little bit of a problem because when x equals 2, I'm roughly here. So I'm looking at this, the equation of this line. But I'm also roughly here. So I'm looking at the equation of this line. So which one? Well, recall we found that dy dx is equal to negative x over y. So this is going to give me the slope at these 2 points. But I need, as you can see here, I need both the x and the y coordinate. So I need to figure out what the x and y coordinate is here. And I need to figure out what the x and y coordinate is down here. So I'll go back to my original equation, x squared plus y squared equals 9. But we said x equals 2. So 2 squared is 4. So 4 plus y squared equals 9. That implies that y squared equals 9 minus 4, which is 5, which implies that y equals plus and minus the square root of 5. So this is going to have coordinates 2 root 5, and this will have coordinates 2 negative root 5. So with that, I can take these coordinates, go back into the derivative, and figure out what the slope of these tangent lines are. So for the first one, I'm going to call the first one m1. So m1 will be equal to a negative 2 over the square root of 5. That's putting these coordinates right here into this. So that means that m2 will be equal to a negative 2 over the negative square root of 5, which is simply 2 root 5. Now this makes sense because notice this is a negative slope. Clearly I have a negative slope here. And this is a positive slope. And clearly I have a positive slope here. So from this we can figure out the actual equation of the line here. So what I'm going to do is use y minus y1 equals the slope times x minus x1. Use this form of the equation of a line. So I have y minus y1. Let's go ahead and use this one first. That's going to be root 5. Equals the slope, which is negative 2 over root 5, times x minus x1, which is 2. Now I did not rationalize this. I guess probably should have or could have. We'll do that later if you want to. It's no big deal. So this would then give me that y is equal to a negative 2x over root 5 plus 4 over root 5. I need to move this over, plus root 5. So that means that y equals negative 2 root 5 over 5. I just rationalized this. X plus, well, if I multiply this by root 5 over root 5 to give me my common denominator, this would be 5. So that's 9 over root 5, which would be 9 root 5 over 5 if you rationalize the denominator. So this would be the equation of my first line, this one right here. And let's go ahead and jump to Maple real quick and take a look and see if that actually works. Now there's a couple different ways I can do this in Maple. I'm going to introduce you to what might be a new way for you. First of all, I'm going to start off with just typing in my equation. X squared plus y squared equals 9. And now I'm going to put in the equation of that line. And the equation of that line is going to be negative 2. And now I'm going to use SQRT for square root. Square root 5 divided by 5 times x plus 9 times the square root of 5 divided by 5. There's my constant. So I'm going to hit enter, and notice this is the equation of my line, and this is the equation of my circle. So when I hit enter, I just have those two equations. So okay, they look good. So what I'm going to do is come back up here and go right click on it, and I'm going to come all the way down here to plots. I'm sorry, 2D plot. Whoops, I forgot. I need to go back up here and make this y equals. And now hit enter. Now what I have is two implicit plots. So when I right click on it, I can come down here to plots and have 2D implicit plot as an option. It's a two-dimensional implicit plot in X and Y. So I'm going to select it, and there's a graph. Maple just made a graph for me. I can do other things like right click on it and scale constrain. That makes a lot of sense. I'm maybe to zoom in out a little bit. And the point here is it seems reasonable, but this line is in fact tangent when x equals 2. So if I complete the same calculation for the other set of coordinates, I'll have, let's see if I can fit it in here, y minus y1, which is a negative root 5, so double negative gives me a positive root 5, is equal to slope 2, which is, oh, this is supposed to be a square root here. I'm sure you caught that when I did it. That'd be 2 root 5 over 5. X minus 2, which would give me y equals 2 root 5 over 5x minus 4 root 5 over 5 minus root 5. And again, I'm going to multiply this by, actually, because I already did this conversion, I need to multiply this by 5 over 5 is what I really need to do. So if I multiply this by 5 over 5 to get the common denominators here, I'm going to end up with y equals, and I just noticed I skipped this 2 here, 2 root 5 over 5. So this could be 2 root 5 over 5x. And then here I'm going to have minus 9 root 5 over 5. So this is my second equation. So I'm going to go ahead and go into Maple and do that, or just simply add that to it. So I'm going to come up here, put in, I need to make sure I'm in this same big box, there we go, a comma, and y equals, and this one was 2 square root of 5 over 5 times x minus 9 square root of 5 over 5. See, now I have all three of these. Each of these are in this form. So if I right click, go back to plots, two-dimensional implicit plot, x, y, what I have now are both of these tangent lines. So if I go ahead and scale, or scaling constrained, what this constraint does is it simply makes sure that the distance on the x-axis matches distances on the y-axis. It's at the same scale. So basically, by looking at this, I can reasonably convince myself that, yeah, I did it right. These are both tangent to the circle at x equals 2.